Okay, guys, so I think we can start now. So last time I explained how can we program the 7 segment, okay? So last time I explained, I programmed only one display, only one, okay? So today I'm gonna explain how can you program more, how can you run or use more than one display, okay? But let me quickly just make a quick revision on what I said last time. What I said last time, guys, was, as you see here, if you want to display number 0, so this is the code you have to send to port P. Because if you send this code, so you are gonna put 1 here in segment A, so you can turn it on. You can turn all, as you see, you can turn all the segment on except G. And if I do that, I can make number 0, okay? So same thing for all numbers here. So every number should have a code. Is that okay? So if I want to display 0, it looks like ASCII code, right? It looks like ASCII code exactly, okay? So if I want to display 0 in the LCD, I have to convert this 0 to ASCII, which is 30, right? Same thing here. If I want to display 0 in the LCD, I have to convert this one to 3F, right? Because 3F is going to display 0, almost the same thing, okay? Then what I explained last time, the way you can do it is, number 1, we created a table like this one, or created array. As you see here, this is the code for 0, this is the code for 1, this is the code for 2, and so on, until 9, right? Until 9. And then if you want to display any number, and the way you made it is, if x is pointing on the first element, so 0, x is going to give you the address for the code of 0. 1, x is going to give you the code for 1, right? And so on. So 7, x is going to give you the code for 7, and so on, okay? So that's all what you have to do, right? So if I need to get the code for 8, so all what I have to read the location 8, x to get this code and send it to port B. This is one thing you have to do, okay? There is another thing you have to do. I explained last time, right? You have to enable the 7 segment, okay? So I told you we have 4 7 segment. I think you can see it in the table. Yeah. So as you see here in this figure, we have four 7 segment. So this one has enabled PB0, PB1, PB2, PB3. Is that okay? So if you want to enable any one of them, you have to put 0. Okay? Usually we are not going to enable more than one at a time. Okay? Otherwise, if I enable 0 and 0, so these 2 displays are going to display whatever on port B. So for example, if port B has a number 5, okay? So if port B has number 5, you will see 5 here and 5 here, which for sure doesn't make sense, okay? So usually we are going to do only one at a time. We are going to only enable only one, right? So last time we ran, I explained how can you use only one. Today I'm going to explain now how I can use the 4. Okay, I think I explained this idea before. If you remember, I told you I'm going to need it later, but I'm going to explain it again. Okay, so the idea is here. Look here, guys. For example, if I want to display number 3, 7, 2, 1, for example, any number. So I want to display this number. Okay, guys. So what I have to do is, number 1, I have 4 displays. So I have to display number 3 here, and the other displays are off, disabled. Okay. So this one is enabled, and the other 3 are disabled. Okay, I have to do that, and then I have to wait a little delay. I have to put a little delay. I'm gonna tell you why. If this delay is too small, it's a problem. If this delay is too big, it's a problem. Okay, I'm gonna elaborate. Okay, so then I'm gonna put a little delay. After that, I'm gonna put here number 7, okay? And I'm gonna turn the other ones off. Is that okay? And then same thing, I have to put a delay here. I have to wait for some time. Then here I'm gonna put number 2, right? And then the other ones are off. Okay. And then here I'm gonna write number 1, the other ones are off. Okay, guys? Then I have to go back and repeat again. You have to go back and repeat again. Is that okay? If you repeat it fast, if you do that fast, you will see it very stable. You will see very stable number. Is that okay? This is the idea. That's what we're gonna do. Okay. What I'm gonna do now, I'm gonna explain. By the way, this is what we call time multiplexing. Time multiplexing technique. We do time multiplexing here, okay? So we call it time multiplexing technique, okay? Someone can ask me why we complicate it this way, okay? Because the other option is bad. What is the other option that's bad, okay? The other option is every 7 segment I can connect it to one port. So here I have 4, so I can use 4 ports, four ports. For sure, that's too bad, right? So in this case, I don't need time multiplexing. I can put here number 3, 7, 5, 8, or 1, whatever. Okay, they are all the time. I don't need time multiplexing. Okay. The good thing what we did right now, instead of using 4 ports, what I did, I used only 1 port, which is port B. Okay. Also, I used 4 bits for enable. Okay. This is so total 12 bits. This is much better than using 4 ports, which can be 4 times 8, right? So 8 bits. 4 times 8 is 32, right? So it's 32 bits, or 32 pins, to be more accurate, 32 pins, okay? So for sure, this idea is too bad to use ports because we don't have too many ports, right? So we are gonna lose the ports. Okay, so we don't have too many ports. That's why usually we do time multiplexing. So what I'm going to explain now is, I'm going to explain how can we program this, how can we do this programming, okay? If you put the time multiplexing task in the main program, okay? So you can put it in the main program. Also, I'm going to explain if you put it in RTI. You got what I'm saying? So you can put this one, RTI can take care of it, right? Is that right? Yes, it's right, because RTI is used if you need something periodic, right? So I have something periodic here. So here I have to do something, here I have to do something, here I have to do something. So periodic. In one interrupt, I'm here. Okay? So in one interrupt, I'm gonna do this one. Next interrupt, I'm gonna do this one. Next interrupt, I'm gonna do this one. Next interrupt, I'm gonna do this one. Okay? Also, you have to make sure the time between each 2 interrupts is gonna make a good delay. Okay? Little time is bad. You got what I'm saying? Long time is bad. Why? I'm gonna tell you why. Okay? So you have to make sure the time between each 2 interrupts is good time. Enough delay. Okay? Let me now tell you if this time is big, if this delay is big. What is long delay? What do you think what would happen?
See one 7 second on, then the next, then the next.
Yes,
then the next.
that's what we call flicker. So you will see flicker, okay? And you will see right now in the video. In the video right now, I'm gonna make a big delay intentionally to see the flicker. You will start to see it's not stable. It's not a stable number. Okay, you will see it right now. Okay, so long delay is bad. Okay, but why small delay is not good? Is bad as well. If you make a very small delay or no delay, if I make no delay, why it's bad? Why I have to put delay? I'm gonna tell you why. Okay, if you make it, but before I say this, look here, guys. If you do time multiplexing using RTI and you see flicker, it means the time here is the time out is long, so I have to reduce it, right? Many students make these mistakes because because in the examples, in the slides, I use 130 millisecond. 130 millisecond or 131 millisecond is a very long time, right? If you use it, if you make interrupt every 131 millisecond, you will see flicker, okay? So if you see flicker, if you run this one using RTI and you see flicker, so what you should figure out what's the problem. The problem you need to reduce that. Okay, now let's return to my point. Why a good delay? Why I can cancel this delay? Okay, or I make it very, very small, right? No, it's bad. I'm gonna tell you why it's bad, okay? If you do that, so the 7 segment is gonna be dim. It's gonna be dim. Why it is dim? I'm gonna tell you why. Because the way LED behave, remember, every segment is an LED, right? The way LED behave is, this is the time, and this is the brightness. Okay, brightness of the LED, okay? It takes some time. It takes some time until it reaches to the maximum brightness. Is that okay? So again, keep in mind, microprocessor is super fast. Microprocessor is super fast. So if I put 5 volt and remove it, okay, after 1 nanosecond or few microsecond, okay, it's not enough. It's not enough for the LED to reach to the maximum brightness. So that's why it's gonna be dim. Is that okay, guys? So let me tell you the conclusion. The conclusion is, if you run, if you can see the LEDs are dim, that means you need more delay. So increase the delay. Is that okay? So I need to increase the delay to keep the voltage. So when I put a 5 volt on the LED, I have to keep it for some time, right? I cannot put 5 volt and remove it quickly, right? And put it in the other one because it's not gonna reach to maximum brightness, okay? So also, if you see flicker, that means the delay is long. You have to reduce it, okay? I'm gonna explain now. I'm gonna show also, I have a very interesting video, but I'm gonna show the video after I finish. I'm gonna explain now how can you do this programming, okay? Using this task, I'm gonna put it in the main program. Also, I'm gonna do it in RTI. I'm gonna explain both, okay? As I told you guys, now your program should have more than one task. Because of interrupts, your program, you can run multiple tasks at the same time. And you need to decide. So if I have 4 or 5 tasks, you need to decide. Should I do the time multiplexing in RTI, or it's better to do it in the main program, okay? Or it doesn't matter, so I put it here, I put it here. That's why, even last time I explained how can you run 7 segment if you put the code in the main program, and also if you put the code in RTI. So you have option, okay? So I'm gonna explain it now. Okay, so I want to display this number, guys. I want to display 3, 4, 5, 6. Okay, so in order to display this number 3, 4, 5, 6, okay, so for 3, I have to put this value in port B because this is the code for 3. Okay, also I have to put this value in port P in order to enable the last one and to disable others. Remember when I told you I have to enable one and disable others? Yeah, that's true. You know why? I'm gonna tell you why. Because E is 0, 1, 1, 1. Okay, and we have here, this is E. Okay, so that means you are gonna enable the first one. Is that the one here? This is, you are gonna enable this one. Okay, so all what I'm gonna do, guys, I have to do. I'm gonna make a loop. I'm gonna make a loop. In the first iteration, I'm gonna put this value here on port P, and I'm gonna put this value on port P. Is that okay? In next iteration, I'm gonna put this value here, 66, which can display 4. I'm gonna put it in port P, and then I'm gonna put this one in port P. If you look at this one again, let me keep. I'm gonna write it here. So here, this one is 0, 1, 1. Okay, 1. because I want to enable this one. This one actually it is 1011. This one actually it is 1101. This one actually 1110. Is that okay? You can see here only every time I only put 10 here because we want to enable one and disable others. Is that okay? So now the program is very easy. Yes, the program is very easy. All what I'm gonna do, guys, I'm gonna make a loop. I'm gonna make a loop. In one iteration, I'm gonna do this. Next iteration, I'm gonna do this. Next iteration, I'm gonna do this. Next iteration, I'm gonna do this. And then next iteration, I'm gonna go back. Is that okay? So after I finish the 4, I have to go back to do it again. Okay? That's what I'm gonna do right now. Okay? So very easy. You will see right now, number 1, I created this table as you see here, guys. Okay? In every iteration, I'm gonna take 2 numbers in every iteration. This one has to go to B, this one has to go to P. Okay? In one iteration. Next iteration, I'm gonna do the same thing, but I'm gonna on those in these 2. Next iteration is the same thing in these 2. Next iteration, I'm gonna do the same thing on these 2, and then I'm gonna go and repeat again. Is that okay? Okay. So how you can do that? I'm gonna explain now. This part is just very easy. Okay, this is the configuration we do all the time. So this is the loop I told you about it. In the very beginning, X is pointing at X is here. X is pointing here. Okay, guys. In the very beginning, X is here, and this is the loop. Okay. This part is gonna loop 4 times. So here, again, so this part is gonna loop 4 times. Okay. After the 4 times, I'm gonna come here to reinitialize X again to make another 4. Is that okay? So X has to start from here. And in the first iteration, I'm gonna take X and then I'm gonna take X plus 1. And then I'm gonna increment X so that next iteration X is gonna be here. Okay, you will see now. So as you see here, guys, I'm gonna take 0, 0, comma X. I'm gonna take the byte pointed by X. I'm gonna put it in port B. And then I'm gonna increment X. And then I'm gonna take next byte, I'm gonna put it in port P. Is that okay? So in every iteration, I'm gonna take 2 bytes. Is that okay? And then I'm gonna increment X. Why you increment X? For next time, for next iteration. So in the first iteration, X is here. Second iteration, X is here. Third iteration, X is here. Fourth iteration, X is here. Okay? And then once I finish this one, I'm gonna return X again here. You will see it now, right now, okay? Then after I do that, so here I put a value on port B, I put a value on port P, and then I'm gonna wait 1 millisecond. Okay, guys? I tried 1 millisecond, I find it's okay. 1 millisecond is okay, okay? If it is not okay, if it is dim, I would increase it, right? If there is a flicker, I would, as I told you, I would reduce it, okay? But I found it's okay, okay? You will see it right now in the video. And then I told you once X come to here, sorry, once X, because every time I take one value, I increment X. So in the last iteration, X was here, and then I'm gonna increment X to here, and then increment X to here. Once X come to here, what should I do? I have to reinitialize it again. Okay, that's what I did here. See how I did it? I'm gonna compare X to display plus 8. Okay, the initial address plus 8. This is gonna happen when X is here. Okay, when after you display this one, after you send this one to port B and you increment X is gonna be display plus 8, right? Because this is the beginning address plus 1, 2, 3, 4, 5, 6, 7, 8, right? So anyway, once we come here, if it doesn't equal, so I'm gonna come here to take another record. If it is equal, so I'm gonna come to here, okay, in order to reinitialize X again. Is that clear? So every four iteration, I'm gonna come here. Okay, guys, any questions? Okay, let me show you the video before I explain the C language. Oh, sorry.
Yeah.
Number 3, 4, 5.
It's a very stable number. Maybe the camera is not that good, but very stable number. You can see here 3, 4, 5, 6. Very stable, right?
Stable. You can see the number is stable. However, this is because
Now I'm gonna change the delay to make flicker to understand why long delay is bad.
look here at the delay.
So here, let me see.
You will not see a stable number.
I think I used 5. Let me see.
Look,
Originally, I used 5 milliseconds. It was okay. I think 1 millisecond also is okay. You can try it and see. But originally, I used 5 milliseconds. In this example, it was okay. Now I'm gonna make it delay is long. Okay. I made it 100 milliseconds. The delay is long. So you'll see now. Can you see? Very clear now, right? You can see the flicker. You can see the flicker. Very clear, right? Now you can see some of them are on and off. Is that okay? Again, if you do this one in RTI, that means the timeout is long. You have to reduce the timeout. Okay? I'm quite sure some of you will make this mistake, okay? Because so far, I'm gonna use the second segment in the coming test, okay? So, but the way I think about it, it's gonna be in the main program anyway. But if you run the time multiplexing using RTI and see flicker, that means the timeout is low. So you try to reduce it, okay? Okay, so now what I'm going to explain now, how can we do the same thing using C? So I'm going to use the same logic. I think I have here, let me see. Yeah, I'm going to use exactly same logic, but in C is easier. In C, because we just use functions, you will see now. So what I'm going to do here, you guys, as you see, this is the number I want to display, 3. Three, 4, 5, 6. Okay, this is the number I want to display. And then, as you see here, guys, this is exactly like what I did in assembly. So I'm gonna make 4 iterations, right? 4. And then I'm gonna repeat them forever. So I'm gonna repeat these 4 iterations forever, okay? So in the first iteration, I is equal to 0, okay? So I'm gonna here it is 0, here is 0, right? Here, element number 0, which is 3, right? So I'm gonna display number 3. Remember this function. I told you this function is gonna do the conversion. So this function I'm gonna give it 3, is gonna convert this one to 7 segment code, right? So don't worry about the conversion. Anyway, so in the first iteration, I'm gonna take this one here, and then I'm gonna display it. I'm gonna enable display number 0. Is that okay? In second iteration, I is equal to I is equal to 1, right? So this one is 1, right? And this one is 1. So I'm gonna take number 4. I'm gonna display number 4 on display number 1. Is that okay? And so on. Same thing for 2, right? Same thing for 3. When this one is 2, this one is 2. So I'm gonna take 4. 4 is here, and so remember how this function works. This function, as I told you before, here you give me a number, okay? The number you want to display. Here you have to tell me which display you wanna which 7 segment display you wanna turn on. So this one should get a value from 0 to 3. Is that okay? Any question? And every time I'm gonna wait 5 milliseconds. Any question? Is that easy? Okay, guys. Okay. So now I'm gonna explain how can you do the same thing. It's the same thing I explained right now. How can we do it using RTI? So I'm gonna jump to chapter 3 to show you how can we do it using RTI. Sorry, I'm gonna jump to chapter 4. As I told you, I have four records, right? So in every interrupt, I'm gonna do 1, interrupt 1, interrupt 2, interrupt 3, interrupt 4, and then I have to repeat again, right? So how I can know if this is record number 1, record number 2, record number 3, record. How I can know? You have to use a counter, as you will see right now. Okay. So look here, guys. So this same thing. This is the table we have here right now. Okay. Okay. This is the table we have. Okay, guys. So so in first interrupt, I'm gonna take these two. Second interrupt, I'm gonna do these two. Third interrupt, I'm here. Fourth interrupt here. Interrupt number 5, I have to go back and repeat again. That's what I'm gonna do. Okay. However, different from what I did in assembly. You know what I did in assembly? I put X here, and every time I increment X, right? I cannot do that in RTI. I cannot do that in RTI, right? Because as I told you, in RTI, registers, every time you increment X, okay, and you leave the interrupt, X is gonna give the original value back, right? That's why I have to use a memory. I'm gonna use a memory location. Okay, I'm gonna call it count, as you see here, guys, count. Okay, so what I'm gonna do, count here, all what I'm gonna do is X plus count, okay? And count, actually, in the beginning, count is 0, so I'm gonna take this one. I'm gonna increment the count, so I'm gonna X plus 1, I'm here, right? And then increment the count, so X plus 2, I'm here. So every time I'm gonna increment, every time I'm gonna increment count by 2, right? And then I'm gonna add count plus X, right? Okay, guys? You should understand, I cannot increment X as I did before, because what's gonna happen? X is gonna take the initial value back after you go back from the interrupt, okay? Look what I did here, and that's very important. Look here, guys. Most of you, because most of the time we use 7F. Most of the time we use 7F because I want to make 131 millisecond delay. So here I cannot use 7F. If you use 7F, you will see flicker because 130 millisecond is too much time, right? So here I used number 10 because this one is going to make much less delay, okay? To avoid making flicker, okay? So let's see how the program is working, okay? So look what I'm gonna do, guys, here. I told you the idea is in count, right? So in the beginning, count is equal to 0, okay? And then I'm gonna take what is pointed by X plus count, okay? I'm gonna send it to port P. And then I'm gonna increment the count. Then I'm gonna take X plus count, send it to port P. And then I'm gonna increment the count, okay? So that next time, X plus 2, right? And then increment the count. Once the count to come to here, I have to return back to 0 again. Is that okay? So count here is like a shift. What is the shift in X? Is that okay? So that's why you see it here. Look here, guys. X, always X is pointing at the first location, always, okay? And then, look here, count, I'm gonna put count in register A. Then I'm gonna take the pipe pointed by X plus A, which is actually X plus count, right? Because A is count, right? X plus count. So I'm gonna take X plus count and then I'm gonna send it to port B, okay? Then I'm gonna increment the count, okay? Then I'm gonna put count in register A, okay? And then I'm gonna take the next one, okay? I'm gonna send it to port P. Then I'm gonna increment the count. Is that okay? So in the first iteration, this is exactly count. In the first iteration, it was 0, and then I incremented twice. Originally it was 0, and then I incremented twice. So after the first iteration, count is 2. Okay? Then I'm gonna do the same thing. I'm gonna take the X plus 2, and then increment it, and increment again, and so on. Once I come to the end, once I finish the for record, so now I'm gonna compare, I'm gonna check if count is equal to 8. If count equal to 8, because I start from 0, right? So if you start with 0, 1, 2, 3, 4, 5, okay, 6, 7, okay? If you every time I increment twice, so once it comes to 8, that means it has to come to 0 again, right? To repeat, okay? So that's what I did here. So I'm gonna compare it to 8, and then if it is not 8, I'm gonna just return. Otherwise, I'm gonna clear count to repeat again. Any question? Any question, guys? Okay. Okay. So I'm gonna continue working on chapter 4 until I finish it. We have just a couple of programs here in chapter 4. So let's see the next program here. I think I did this one, right? Yeah. Yeah. Okay. So let's do this program. Let's do this program, and this program is important because it's going to be too close to what I want to do in the coming test. Okay, it's going to be too close. Let's see what I want to do here, guys. Very interesting program. What I want to do here, guys, is I want to write a program to count from 00 to 99. Okay. After 99 should be 00 again. Okay. On the 7th segment. So I'm going to use two displays. Okay. I want to increment the count every time IRQ is interrupted. So every time IRQ is interrupted, I have to increment the count. Okay. So the source of this interrupts can come from a sensor that's counting events or counting something. Okay. So here this count can tell you, for example, you can put a sensor, okay, this way, okay. Every time you cut this line, you actually trigger IRQ interrupt so that you increment the count. I want to count how many times this event happened. Okay, whatever this event is, okay. It can be customers entering a store. It can be cars entering a garage, and so on. Okay, so every time IRQ interrupted, I wanna increment this account. Is that okay? So let's see how we are gonna do this program. Okay, guys. So here, number one, what do you need? What do you need to do this program? What I need? What tasks? Okay. Number one, for sure, it's very obvious. IRQ, every time IRQ is interrupted, it has to increment the counter. Yes, that's true. So every time it's interrupted, I have to increment counter. This is number one. Yes. Number two, okay. I need to display this counter on the 7th segment using time multiplexing. Is that okay? So I need two tasks here. Okay. So here I decided to put the time multiplexing in where I put it, RTI or yeah. So here I decided to use RTI to do the time multiplexing. Is that okay? So you can use the main program if you want, but I decided to use. So now I have two tasks, right? Task number one, IRQ. Every time IRQ is interrupted, I have to increment the counter. Is that okay? This is task number one. Task number two, and now I wanna display time multiplexing. I wanna display in the 7th segment. So I decided to put this task in RTI. Okay? Don't ask me why. Okay, you can put it in the main program if you want, right? So I have two options. I decided to put in RTI. Okay. So now, but we have a little problem. What is the little problem we have? I'm going to tell you what is the little problem. Look here, guys. Let me explain it here. I told you what we want to do. Every time IRQ is interrupted, I'm going to increment the counter. Is that okay? Yeah, that's all what I'm going to do. Every time it's interrupted, I'm going to increment the counter. And then RTI is going to take this counter, is going to display this counter, right? Display counter on 7th segment. Is that okay? That's exactly what I want to do. Is that right? But we have a problem. What is the problem? The problem is this number is binary number. But what I have to put in the LCDs, it has to be decimal number. So I need to convert. No, I didn't understand it yet. What do you mean this is binary? And I'm gonna elaborate. So for example, let's take another easy number. For example, 1, 1, 1, 1. 1, 1, 1, 1. This is easy number, I use it all the time, okay? So this is a binary number, right? This is what counter can give you. This is what I'm gonna get from counter, right? This is a binary number, is that right? So this number should be 255, is that okay? So if I wanna display this number on the 7th segment, I cannot, right? So I have to do a conversion here. This conversion should take this number. This conversion is called binary to decimal conversion, okay? So it has to take this number and then it has to give me digits, 2, 5, 5. If you give me digits, I can display it on the LCD. I can display them on the LCD, or I can display it to the 7th segment, right? You got what I'm saying, guys? So I need to do this conversion because this is binary. I need to convert to decimal numbers. Is that okay? So if I want to display this on LCD, for example, I'm going to add 30. I'm going to add 30. I'm going to add 30, and then I'm going to send to LCD. Right? I'm going to add 30 because I'm going to convert to ASCII. Is that okay? If you want to display them, if you want to display this number on the 7th segment, so you have to convert these numbers to code, as I said before. So I'm going to make a table. I'm going to make a table as we did before. So 2 has to be converted to 7 segment code, right? This one has to be 7 segment code. 7 segment code. Is that okay? Okay, guys. Any question? So what I'm going to explain now, how can we do this conversion? But before I do that, I want to make sure everybody understand what I mean by conversion and why you need conversion. Any question? I assume you understand what I mean by conversion and why I need conversion, okay? Because my counter is binary, right? I need to extract the decimal numbers from this one, okay? I'm gonna tell you how, very, very simple idea, okay? So, the way we can do that is, you have, look how it is interesting. We have 1, 1, 1, 1, 1, 1, 1, okay? Which is 255. Is that okay, guys? Look here. So all what I want to do from this binary number, I want to extract 2, I want to extract 5, I want to extract 5. That's it. Right? I want to extract 3 digits from this binary number. How I do that? I'm going to tell you. Very easy. Look here, guys. I'm going to divide by 10. I'm going to keep dividing by 10. I'm going to tell you why by 10. Okay? When I divide by 10, I'm going to get a quotient binary, which is 25. And then the remainder is going to be 5. So I'm going to get, as you keep dividing by 10, you are going to get the digit one by one, but from right to left. So now, this remainder gives me 1 digit. Is that okay? Then, I'm going to take this quotient again, which is binary. I'm going to divide it by 10 again. When I divide by 10, I'm going to get a quotient, okay, which is 2. And then I'm going to get a remainder, which is 5, okay? So this remainder give me another number. So here, I got them one by one, this one. Is that okay, guys? Any question? You got the idea? Divide by 10 so that, for sure, because this number is less than 10, I don't need to divide again by 10. I'm done. That's all. So now my digits are, so now I got 1 here, I got 1 here, the third one is here. Okay? This can work for any other number. I just selected 255 because I know the binary of 255. You put any number, any other number is gonna work. Okay? Any questions? Is that clear? Okay. So also I'm gonna explain another idea that doesn't need this conversion. So I'm gonna now explain 2 ideas. One, this one. Okay, so here I told you in IRQ, I'm gonna create a binary counter. Every time IRQ is interrupted, I'm gonna increment the binary counter. Is that okay? Because the counter is binary, I need to convert it to decimal. That's true, as I explained right now. Is that okay? I have another idea. Okay, what is this? What is this idea? I'm gonna tell you what's the idea. Okay, remember in our example, I told you we are gonna count from 00 to 99, right? So it's only 2 digits, right? So again, it's 2 ideas. Whatever you like, it's okay. I just wanna give you different ideas. Okay. The second idea is I have 2 digits, right? For example, it's 27. Okay. So when I increment it, so every digit I'm gonna put it in a byte. Is that okay? This one is gonna, so I'm gonna have 2 bytes, 1 for each digit. Is that okay? And then the way when I increment, the way I'm gonna increment is I'm gonna keep this number decimal. Okay? How? This is a byte. It can take a value from 0 to 255. But I'm not gonna allow this one to go to 2, maximum 9. Okay, I'm gonna tell you how. So let me explain it. Okay, so it's 27. Now, how IRQ is gonna increment? Okay, how I'm gonna increment? Look here, guys. I'm gonna take the first byte. I'm gonna add 1. So now it is 8. Is that okay? So okay, so it's 8, and then I'm done. Okay, so then I'm done. Okay, so if I increment the first one, and the first one is less than 10, okay, it's not 10, so I'm done. Okay, so and then next time when I increment, I'm gonna take this one increment, right? So this one is gonna be 9. Okay, I'm done. Once, so I'm gonna increment this first digit, and if it is less than 10, I'm done. Is that okay? So although they are 2 bytes, but I'm gonna keep the number here decimal. The format is this. I'm gonna tell you how now. Okay. Now I want to increment now. When I increment, this one becomes 10, right? Keep in mind this is a byte. A byte. It can take number up to 255. Okay. So now it is 10. Now because it is 10, what I'm gonna do, I'm gonna put here 0. Is that okay? And I'm gonna increment the next one. You got it? So I'm not gonna allow any digit to have a number greater than 9. Okay, anyway, so if you don't like it, that's okay. Okay, there's another way. So what I did here is the way I did the increment. Okay, I did increment here so that I'm gonna keep the decimal number this way. So I don't need conversion. Okay, so I'm gonna just take these 2 numbers. Is that okay? Okay, or the other idea, you can just increment the counter, but in this case you have to divide by 10. Okay, that's what I'm gonna do now. So let's see what I did here, guys, in the program. So what I did here, guys, in this program is, as you see here, number 1, for sure I need this table, as I told you. I need this table because this table or this array, whatever you want to call it. So this array is going to help me to do the conversion, right? If my digit, so all what I'm going to do, digit plus x is, so x is here, all the time x is here, okay? So if I want to get the code of a certain digit, so I'm going to go to the location x plus digit. Is that okay? So this is number 1. Number 2, because I'm gonna use 2 7 segment. So this is the code. This code has to go to port P, and this one has to go to port P. Okay. So in one interrupt. So now I have 2 digits. Is that okay? I have 2 digits, and I have two values for enable. for enable. Okay. So what I'm gonna do is, in one RTI interrupt, I'm gonna take one of these values. So in the first interrupt, this one is gonna go to port P, and then digit one, I'm gonna go and get the code of digit one and send to port P. That's exactly what I'm gonna do. So now I have 2 digits, as you see here, guys. I have 2 digits. This is the 2 digit I want to display. Is that okay? So in one interrupt, what I'm gonna do in one interrupt, I'm gonna get digit 1, and then I'm gonna convert to code, go to port P, and then I'm gonna get the first one here, go to port B. Next interrupt, I'm gonna get digit 2, I'm gonna convert it to code, and then go to port P. And then here, I'm gonna take this one to port P. Second interrupt. Third interrupt number 3. So I have to repeat again because I have 2, right? So interrupt number 3, I have to take this one, port P, and then I have, so let me write in a better way. So here, actually, as you see here, we have 2 digits. So I have digit 1, and I have digit 2, right? So all what I have to do, in one interrupt, I have to work on these 2, but for sure you have to convert this one to code using this one. Also, in next interrupt, I have to work on these 2. Next interrupt, I have to come here. Next interrupt here. Next interrupt, I have to come here. Is that okay, guys? Okay? How I can do that? How can I know? In this interrupt, I have, so one interrupt, how I can know in this interrupt, I have to display digit 1 or digit 2. How I can do that? Okay? The way I'm going to do it is, I'm going to use a counter. This counter should take one of 2 values, 0 or 1, as you see here, guys. So this counter has to tell me, so in one interrupt, this counter is 0. So if this one is 0, so I'm going to display counter digit number 1. Is that okay? Then I'm going to increment it. So now it is 1. Okay, in the code, in the RTI, I'm going to increment. So now it is 1. Okay? Because it's 1, I'm going to display 2, right? And then I'm going to clear it. So you'll see right now how we do it, okay? So let's see first RTI. So this is RTI, guys. This is RTI. Number 1, every time IRQ is interrupted, number 1, I'm going to increment the number. So this number should counter. It's a counter, okay? By the way, don't forget, because I think we need it in test 2, okay? Here, this number is a byte, so it's okay to say increment a byte. That's okay. I think in test 2, you need to increment a word, so you cannot say increment for a word. So you have to add 1. Is that okay? Don't forget this one. Okay. So number 1. Here it's okay, I need a byte. Here it's okay, I need a byte. Why? Because the limit I have from 00 to 99. That's okay, that's more than enough. Because byte can store number up to 255. I just need until 99, okay? So here what I'm gonna do, guys, number 1, in every interrupt, I'm gonna increment the number. Is that okay? And then I'm gonna compare number to 99, okay? I'm gonna say, if it is less than 99, I'm okay. Go to conversion. Now convert this binary to decimal. I'm okay. However, if it is more than 99, which means it is 100, so in this case, I have to clear number. Okay? Because after 99, I have to go to 00 again. Is that clear? Okay, guys. Again, every interrupt, every IRQ interrupt, I'm gonna increment a binary number. And then I'm going to check if this one is 100, so I'm going to make it 00, because after 99 has to come 00. Okay, that's what I did here. The last part I did here is this binary to decimal conversion. So I'm going to convert this binary number to decimal, and then I'm going to store the 2 digits here. I'm going to store the 2 digits here, okay? Why? Because RTI is going to take them from here. You get what I'm saying? So IRQ is going to update this digit. RTI is going to display these digits. Is that clear? So That's what I did. As you see here, guys, look how I did here. I got this number, I put it in port P, and I clear port A. You know why? Because when I divide, I have to divide register D. So register D is two parts, P and A, right? So I'm gonna put here 0, and then I'm gonna put my number here. Is that okay? Because my number is enough to be in a byte. That's why I'm gonna put 0 here, okay? So now my number is in register D, okay? The extension, I did extension because the division has to work in register D. I did extension, okay? And now I'm gonna put number 10 in register X. Why? Because now I'm gonna divide D by X. D should have my number and X should have number 10. That's exactly what it is. So here I did division. After I did division, okay? Now the quotient is in X. Quotient is in X, okay? The remainder is in G. Remainder is in G, right? As I told you before, this remainder should have 1 digit, okay? So, however, look here, guys. This remainder in G, but actually I'm gonna take only B. I'm not gonna care about A. Can anyone tell me why? And that's what I did. Look what I did. The remainder, which should have 1 digit, it's already in register D. But what I'm gonna do, I'm gonna send B 2 digits. Okay, so I'm gonna store B in digits. Okay, in the memory location. Okay, can anyone guess why? I think I said it before. Because when you divide by 10, I can guarantee the remainder is always less than 10. So the remainder should be a value from 0 to 9. And 0 to 9, it should be in 1 byte. So that's why, yes, this division instruction is gonna store the result in a word, but because the number is small, so it's gonna be only in B. Is that okay? So that's why I'm gonna take B here, okay? So now I got the first digit. Now where is the second digit? I don't need to divide again. Why? Because I have only 2 digits. It's not 3, right? So here, for example, if it is 72, if I divide by 10, so here the remainder, the quotient is gonna give me 7, and the remainder is gonna give me 2, right? So this is 1 digit, and this is the second digit, okay? So what I did after that is, now the remainder is in X, okay? Sorry, the quotient in X. But again, this quotient should be less than 10, okay? So what I did, I exchange X with D. So I put it in G. Why you put it in G? Because I just want to take only 1 byte. I cannot do that with X. I cannot take 1 byte from X, but I can take 1 byte from here, okay? So, and then this byte, I'm gonna put it in the second memory location, okay? Any question? So let me tell you the conclusion here, guys. The conclusion is, every time IRQ is interrupted, okay? Number 1, I'm gonna increment the number, this number 1, okay? Number 2, I'm gonna check if this number is 100, I'm gonna make it 0. Because after 99, it should be 0, 0, okay? That's what I told you, okay? That's what I did. Number 3, this part here. I'm gonna take number, and then I'm gonna get 2 digits, decimal, by dividing by 10, right? I'm gonna get two decimal numbers, okay? One number, I'm gonna put it in digits, in the memory location digits. The second one, I'm gonna put it in memory location digits plus 1, because if you go back here, this is digits here, okay? Okay, so every time IRQ interrupted, IRQ is gonna update these 2 memory locations. RTI, what RTI is gonna do? It's gonna take whatever here, display on the on the 7th segment. So let's take a look on RTI. So this is how RTI works. I told you I'm gonna use count. So count in one interrupt it is 0, next interrupt 1, next interrupt 0, next interrupt 1. It has to go this way, okay? So it has to have 2 values. Because when it is 0, I can know this is the time for digit 1. Okay? When it is 1, I can know this is the time for digit 2, right? So digit 1, digit 2, digit 1, digit 2, and so on. Okay? Every interrupt, I'm gonna write only one number on the 7th signal. Okay? So let's see how it works here. Number 1, x is gonna point at the beginning of the table here. So what I'm gonna do, guys, is look here. X is pointing here. This is x. Is that okay? So all what I have to do, I'm gonna add x plus the digit. If I add x plus the digit, this should give you the address for the code. And then I'm gonna take this one to port B. Is that okay? But the question is that which digit you are gonna take, the first or second? Count is gonna tell me, count. That's what I did here. So if you see here, guys, so here, Y digits is two memory locations. This is array for 2 memory locations. Is that okay? So here X is the 2 memory location, one for digit 1 and one for digit 2. Is that okay? X is pointing here at the very beginning. Okay, and sorry, Y, as you see here, Y, and then I'm gonna add here. I'm gonna put count in B, and then I'm gonna add Y plus P. So here this one, Y equal Y plus P. Is that okay? And because count one time is 0, so and one time is 1, one time is 0, one time is 1, 0, 1, 0, 1, 0, 1. Because of that, in one interrupt, I'm gonna add 0 to Y, so I'm gonna get digit 1. In next interrupt, I'm gonna add 1 to Y to get digit 2. Next interrupt, I'm gonna add 0. Did you see? Can you see the pattern of count here? So count 0, 1, 0, 1, 0, 1. It should be this one. Okay. When I add 0 plus Y, I'm gonna get to the first digit, the address of the first digit. Next interrupt, when it is 1, Y plus 1, so I'm gonna take the second digit. Okay. The address of the second digit. Okay. That's what I did here, as you see, guys. So what I did here, Y is pointing on the first digit, and then I'm gonna add count plus Y. So now Y is pointing as the correct number, as a digit I have to display. Y is pointing at the digit I have to display. Okay. So okay. So what else you have to do? Okay. Now I got the digit. I know the digit, right? That's how it is. So one time here, one time here, one interrupt here, one interrupt here. I have 2 digits, right? So now I got the digit. What should I do? I have to convert this digit to code. That's what I did here. See what I did? So here, I'm gonna read this digit. I'm gonna read this memory location, which would give me the digit. I'm gonna put it in A. And then to convert it to a code, so I'm gonna go to the table X here. I'm gonna get the value. I'm gonna get the number at X plus A, right? As I told you, X plus 0, I put the code for 0. X plus 1, I put the code of 1, and so on. Okay. So here, 0, 1, and so on. This is a digit. Okay. Because this digit, I put it in A. So I got 1 digit, I put it in A, and then I got the code I sent to port P. So I'm okay with P. I finished P. Now I have what is remaining here. I have to enable, right? So also port P, I have to enable, right? The way I'm gonna enable, guys, as I told you, is let's come here. I have 2 numbers. So I have 2 numbers. Okay. So in one interrupt, I'm gonna be here. Okay. Next interrupt, I'm here. Next interrupt here. Next interrupt here. Okay. How can you do that? I'm gonna tell you how. Very easy. So the way I'm gonna do it is, if X is here or Y, whatever you call it, if X or Y, so I can add plus count. Is that right? So if count is 0, so X plus 0, I'm gonna take this one. Next time count is 1, so X plus 1, I'm gonna take this one. Next time count is 0, I have to force the count to be this pattern, 0, 1, 0, 1, 0, 1. Okay? So that one time I'm gonna, again, same thing, what I did in digit, I'm doing it here also again. So here, okay, so here, when count is 0, I'm gonna take this 2. When count is 1, I'm gonna take this 2. And then next time it has to be 0, right? So that's what I did. X is pointing at the first location. count. I'm gonna put count in A, and then I'm gonna take the byte which x plus A or x plus count. Is that okay? So in one interrupt, count is 0, one interrupt is gonna be count is 1, okay? Then I'm gonna put it to port P, okay? So what else remaining? So now I put one value to port P, I put the enable to port P. I'm done. Yes, I'm done. But I have to update count, right? So, so what I'm gonna do, as you see here, guys, I have to increment the count. Is that okay? And now, if count is 2, I have to make it, I have to clear it, right? Because count has to be 0, 1, 0, 1, 0, 1. If it is 2, so I have to make it 0. If it is 1, okay, I increment it now, it is 2, no, I'm gonna make it 1 because after 1 has to come 0, okay? Is that clear? Okay, guys? So let me ask again. Why I used the count here? Why? Simply because here, in one interrupt, I have to take these two values. Next interrupt, I have to take these two values. Okay? So count is gonna help me. Okay? So here, X is gonna point at the first location and then I'm gonna add count. So that's why count has to be 0, 1, 0, 1. Is that okay? So count plus 0, I'm here. Sorry, X plus count plus 0, I'm here. Next time, X plus 1, I'm here. Next time, I'm here, and so on. Is that okay? Let me ask you a question. In this program, I use only two displays. Is that okay? If I wanna change this program so that I use 3 displays or 4 displays, what would I do? It's easy, right? What I have to do is, number 1, now if I use 4, now I have 4 digits, right? So this array has to be 4 because now I have 4 digits. Is that okay? So I have digit 1, I'm gonna say D1, okay? So in one interrupt, I have this one has to go to port P, okay? And this one, I have to convert to code and then go to port P. That's true, okay? Next interrupt, I'm gonna digit 2 with this one. Is that okay? Third interrupt, so I have to put the enable, I have to put 2 more. This one enable for display 2, this one is the enable for display 3. And this is digit 3, and this one is digit 4. So now what I'm gonna do, one interrupt I'm here, interrupt 1 I'm here, interrupt 2 I'm here, interrupt 3 I'm here, interrupt 4 I'm here, right? After interrupt 4, I have to come to the beginning again. How can we do that? This is similar to what I did. I'm gonna do a little modification. What should be count now? What should be the pattern of count now? Count has to be 0, 1, 2, 3, and then this is the pattern, repeated. 0, 1, 2. So it's not 0, 1. It's not 0, 1, 0, 1, 0, 1. No. Why? Because when I put X here, X plus 0, I'm here. X plus 1, I'm here. X plus 2, I'm here. X plus 3, I'm here. Little bit modification to this program. That's why I'm asking here. Question. Yeah. Can you extend this program so that you can display 4 displays? Yeah, little bit modification. So count now. So I have to change this one. So once count is 4, because count, once it is 4, I'm gonna clear it. Is that okay? Because count has to be 0, 1, 2, 3. Okay. Anyway, any questions? Only one thing is missing. Okay. Here, I told you guys, if you wanna increment is a number, I told you there are 2 ways. One way, I think I have a video here. I'm gonna show you the video. One way is I'm gonna increment a binary number and then I have to convert this binary number to digits. That's what, by dividing by 10, right? I told you I have another idea, okay? You remember what I told you? I have another idea. So I'm gonna show what is the program for the other idea. So this is the other idea. Look how I made it, okay? So here I don't need to I don't need to convert. I have 2 bytes, 2 digits, digit 1 and digit 2, right? I have 2 bytes. When I increment these 2 bytes, I'm gonna increment them in such a way to keep them decimal all the time. You got what I'm saying? So I'm not gonna allow one of them to be more than 10. Also, it is a byte. It's a byte. It can take up to 255, but I'm not gonna allow it. So see how I did it here, guys. So now I have, this is digits here. So X is pointing at digit. Remember, digit should be two location, now 2 digit, right? So this is the array. So it should be 2. So X is pointing at the first one. Okay, see what I'm gonna do. Look here, guys. I'm gonna increment 0, X. So I'm gonna increment the digit 1. So this is digit 1. And this is digit 2. Okay, so I'm gonna increment digit 1. Okay, if digit 1 less than 10, I'm done. Okay, so that's what I did. So look here, guys. And then I'm gonna compare, I'm gonna read it, I'm gonna compare it to 10. And then if it is less than 10, I'm done. Okay, so I'm gonna increment the first digit, the least significant digit. If it is less than 10, I'm done. Okay. Now, if it is 10, what should I do? I have to clear 0, X. Remember, 0, X is going to be digit 1. 1, X is going to be digit 2. Okay. So 0, X, I'm going to clear it, and I have to increment 1, X. I have to increment the second digit. Okay. So if this one is 10, if you have 2 numbers, for example, 19, for example. Okay. I increment this one, so this one become 10. No, I'm gonna make this one 9. Sorry, I'm gonna make this one 0 here. This instruction here, I'm gonna make it 0, and then I'm gonna increment the second one, so that after 19, 20 should come. Is that okay? The last part here, I'm done. No, you're not done. Why? Because also you have to check this one. It should not be more than 9, right? It should not be. That's what I did here. So here, I'm gonna check this one. If it is less than 9, it's less than 10, I'm done. Is that okay? Now, if this one is 10, if this one is 10, right? What it means? It means, okay? It means I have to increment, I have to clear both of them, because this can only happen when it is 99. So look here, guys. When it is 99, I'm gonna increment the first one. First one now is 10. No, it's not allowed. So you have to make it 0, okay? And then next one here, okay? Now it is 10. No, it's not allowed. I'm gonna make it 0. So now after 99, I'm gonna get 0, 0. I think I wrote here. I don't need to clear. I don't need to. I'm not sure why I cleared the 2 digit. I think because this one should have done here already. Okay, so I think try to remove this one and see if it's gonna work or not. I think you only have to clear this one because it's already, we cleared this one already. Okay. Anyway, it's not wrong, but we don't need it. Okay, guys. I'm gonna show a video now how this is gonna work, but the way I'm gonna do it, because I don't have like sensor, okay, to connect to IRQ. So I'm gonna connect it to push button. You will see right now, every time I press a button, you will see the number is incremented, okay? Very interesting, you'll see the number now. So, look guys, every time I press a button, I increment it, okay? In reality, or it depends on the application, this press is gonna come from a sensor. It's gonna come from a sensor. And that's what we're gonna do in the test, in the coming test, okay? So in the coming test, this is, in the coming test, I wanna do something like that. I wanna count event is coming, okay? In order to simulate this event, I'm gonna ask you to connect the function generator, right? So like the function generator is like a sensor that gives you events. Is that okay? So that means IRQ is gonna be incremented every falling edge. Every falling edge is gonna be incremented, okay? It will be interesting, it will be easy, but it's gonna be learning. You're gonna learn. Okay, guys. So you can see after 19, look, it comes to 20. Okay. Anyway, any question? Okay, guys. Okay. Now, I'm gonna make a very little modification. Okay. And then I'm gonna make another program that's very interesting. Okay. What I'm gonna do now, I wanna count from 00 to 99, okay? But this counting is not gonna be, I'm not gonna increment the count every time IRQ is interrupted, okay? I wanna increment every 1 second. So it's gonna be like a timer, right? So it's exactly the same code. But the increment part, so it's gonna be almost the same code. But this part, when I increment here, when I increment a number, this one I'm gonna put it in RTI. Every 1 second, I'm gonna increment. Every 1 second, I'm gonna increment. You got what I'm saying? Because I wanna make a timer. Let me show you how it's gonna look like. Very interesting. This one, okay. So what I'm gonna, look here, guys. So here, RTI is gonna do the counting. So every 1 second, okay, I'm gonna tell you what is interesting about this program is I'm gonna give you 3 tasks. What 3 tasks, right? So what are the 3 tasks? Okay, number 1, we need to increment. The counter, okay? This will be done by RTI. Every 1 second, I'm gonna increment. Also, I have to convert to decimal. It's the same code I used right now in IRQ. I'm gonna take it and put it in RTI. Is that okay? Every 1 second, I'm gonna increment the count. Okay, this is RTI. Okay. Number 2, time multiplexing. Who's gonna do the time multiplexing? Okay, I'm gonna put it in the main program. Task number 2. Okay. Task number 3, I wanna IRQ to help me if I wanna stop the counting. So every time I press a button, I'm gonna stop the counting or resume the counting. You got what I'm saying? Very interesting. So I'm gonna do now 3 tasks. Okay, 1 task to stop and resume, and this is IRQ. Okay. How I can stop the counting? Who's doing the counting? RTI. So I'm gonna disable RTI. Very simple, right? If you disable RTI, its subroutine is not gonna be called. So no counting. What I'm saying? So now I have 3 tasks, guys. I'm gonna use, maybe this is the first program. I use the main. Now I used everything we have right now. Okay. I have IRQ, I have RTI, I have the main program. So I'm gonna use the 3. Okay? So let's see how it works. So here it's like a timer. And this code, the code is similar to what I did right now. But I'm gonna take the code of increment that was in IRQ, I'm gonna put it in RTI. Okay? So you will see now. Should be after 99, it has to come to 00, right? When I press the button, see what I did? I disable RTI. So that's why counting is not working, okay? When I press again, I enable. Okay, so here, because this button is connected to IRQ. Very interesting, okay? So let's see how I made it. So let's start with RTI first, or the easy one. The easy one is IRQ, okay? In IRQ, look here, guys, IRQ, this is a very easy one. As I explained last, I think we did the same thing in another program. So every time IRQ is interrupted, I'm gonna flip 1 bit. Very easy, just 1 bit. 1 bit in this register, CRGINT. You flip 1 bit, that's it. Because this bit is the enable bit for RTI. Is that okay? You flip 1 bit. So as you see here, every time I press a button, I'm gonna flip 1 bit. Okay? If RTI is enabled, I'm gonna make it disable. Okay? Again, when you disable interrupt, that means I'm gonna stop the task, right? Because it's a subroutine, it's not gonna be called, right? So it's not gonna count, because what is the counting? The counting is done in RTI. So if you don't call RTI, you are not gonna count. You got what I'm saying? So this is here. Now, what about RTI? Very easy. Look here, guys. It's the same code I used right now. Okay? Here, this is the same code I have just explained right now. Okay? To increment but this code I'm gonna put it here in ArcGIS, okay? And I'm gonna do it every 1 second. That's why you can see, guys, I'm gonna increment ArcGIS count, okay? And then if it is not 0, I'm gonna come here. Sorry. So every 8 interrupts, I'm gonna do this part here every 8 interrupts. So here every 8 interrupts. So every 1 second. So every 1 second, I'm gonna increment the count by 1. This is exactly the code I explained right now. That was in IRQ. I put it here. Any question? So I'm gonna update the 2-digit. I'm gonna update the 2-digit. These 2-digit. I'm gonna increment them. Okay. So that the main program is gonna take these 2-digit and it's gonna display them. Got it? Okay. So here I'm gonna update 2-digit, the main program. So now let's go to the main program. So the main program here, what I did, I do time multiplexing here, okay? So this is also similar to what we did before. So I have a count. Also, I have here for the enable, I have two values for enable. For digit, I have 2 values for digit. So when in one iteration, okay, it was 1 interrupt before. When this one was in IRQ, in 1 interrupt. Now in 1 iteration, I am gonna do this part. In the second iteration, I'm gonna do this one. So let's see now, okay? So in 1 iteration, I'm gonna add count plus y. So y is here, okay? So that if count is 0, I'm gonna take this digit. If count is 1, I'm gonna take this digit, okay? So 1 iteration here, 1 iteration here, 1 iteration here, 1 iteration here, okay? Then after I get the digit, so y, so after I do this part here, y is pointing on the digit I have to display right now. So I'm gonna take this digit, I'm gonna put it in A, and then I have to convert this digit to code, 7-segment code, and send to port P. So port P is done. Okay. Now what's left? What is left? Port P, right? To enable one of them. Okay. So this is the easy part. The way I did it is y or x here, as you see here. X is, again, we have 2 numbers. Let me go back. Just I want to remind, yeah. We have 2 numbers here, guys. X is pointing here. X is here. X is here. And then I'm gonna add count. So when count is 0, I'm gonna take this one, and then I'm gonna display it to port P. When count is 1, I'm gonna take this one. So one iteration here, 1 iteration here, 1 iteration here, 1 iteration here. Okay. Very easy, right? Nothing new. I just, you know what I did? I just shuffled. I did shuffling. The time multiplexing here, it was in ArcGIS, I put it in the main, right? And the counting increment was in IRQ, I put it in ArcGIS, right? So here, then I'm gonna add count. So it's gonna be X plus count, and then I'm gonna put it port P. Are you done? No, I'm not done. I have to update count, okay? As we did before. So I'm gonna increment the count, and then if it is 2, I have to clear it, I have to make it 0. Okay? Any question? Do you have time? Okay. So here, I think I finished this chapter. Only 1 program is left. Okay, and we still have 2 minutes, so I can say something about this program. Okay. Again, same thing, guys. If you can update this program easily, that's why I give you here. I'm asking you, can you extend? Yeah, this the one that is counting. Can you extend this program to display 4 displays? For sure you can. As I said before, you should have 4 displays and instead 4 digits instead of 2. The enable here has to be 4, right? Count is a pattern of count should be 0, 1, 2, 3, and then 0, 1, 2, 3. Okay, so you have to do all these changes. Okay, so the last program I have here. Okay, so let me explain. I'm gonna explain it next time. Okay, so I'm gonna explain this program next time, and then I finished chapter 4, but still I have some stuff to do in chapter 3. Okay.
My settings segments don't work on this one.
Okay.
Could I get a different board possibly?
Okay. So let me end the meeting.